Welcome to the video covering the effective voltage and current and as it's used in the power equations. Now, we are really focused here in the sinusoidal signal, and if you're interested, you can go back and read all the details in the earlier videos regarding RMS values. But here, basically, what we're doing is we are renaming the RMS value as effective, because in power systems, people, when they talk about power system, if you've got a V of t, it's going to be the maximum value time cosine of omega t plus a phase, right, for voltage. Now, this is the instantaneous voltage, if you want to think about it that way, because it's really talking about the voltage at any given point of time. And this talks about the peak value or the amplitude or the maximum value of the voltage you have. Now, in some cases, when we talk about power, we are very much interested in the root mean squared of these value, which when you think of it, so we used to be calling that one RMS value. And if you remember how we calculated that, we basically square V of t and then take a derivative over a period, and then we take a square root of it. But since this is a sinusoidal signal, this signal will get reduced very quickly to its V RMS value being equal to V max divided by square root of 2. That's just the way that simplifies to. Now, when we're talking to the power systems and people who deal with power, they don't like to use the word RMS. Rather, they like to use the word effective. So if you ever hear V effective, it's just basically the maximum value of the voltage, the square root of 2 if it's V effective. Same thing is true for I effective. So if you've got I of t equals to Im cosine of omega t plus theta I, and they ask you for an effective value, then you can just say, oh, what they're really asking for is I effective. It's really what we used to do as IRMS. And since this thing is sinusoidal, I don't have to go through squaring it and taking an integral over a period and dividing it by a period. All I have to do is take the V maximum, I maximum in this case, sorry, because we're talking about the current, divided by square root of 2, and that becomes the effective value. So why do they do that? Well, the reason they do that is because they are interested in writing the P, which was the real power or the average power, which was written as I max, V max divided by 2 times cosine of theta V minus theta I, right? So instead of writing it this way, they now can write P in terms of I effective. It's not a big deal, but it's probably worth, it's enough of a confusion. So basically, since this 2 can be written as square root of 2 times square root of 2, then you can take Im divided by square root of 2, write it as I effective and V effective. And then your Q, of course the cosine is still there. And then the Q, you can do the same thing as well. All right, let's go ahead and continue with this thing. And so this would be cosine, cosine, let's go with the same color if I can find it, cosine of theta V minus theta I, and so that becomes your real power equation. So yeah, as you can see, all I did is basically replaced Vm over square root of 2 with V effective, and Im over square root of 2 with I effective. This is just getting the terminology right, okay? Now the other thing we want to do, just to be complete, I'll go ahead and write the other part as well, where when you have Q, if you remember Q, which is the reactive power, was written as Vm Im or divided by 2 times sine, in this case, sine of theta v minus theta I. They'll play the same trick. You write this as a Vm over square root of 2, Ims over square root of 2, and use the V effective, I effective to replace it. So Q is written as V effective, I effective sine theta v minus theta I. So you just got to be careful when you're looking at problems in this space or working on trying to come up with solutions in this space, to be very careful and listen to whether they're giving you the maximum value or the effective value. Things that do get a little trickier in this space is that sometimes they won't tell you what they're giving you, but in reality they're giving you the effective value. So if they are silenced, whether this voltage value they're giving you is a maximum or not, then most likely you should assume that's an effective value and use it as such. That's pretty much all that has to do with that. And before I leave this whole topic, even though it's not our focus of conversation here, but I wanted to make sure this is at least mentioned so you remember it from the earlier conversations that we've had about RMS value. Let's say someone comes to you and give you a signal instead of being. Remember, if it's a sinusoidal signal, you're all set. Just divide it by square root of 2 and you're done. But sometimes they might come in and give you a signal that look like this. Maybe this is 3 volts. This is maybe even weird. Like instead of being even, this is minus 4 volt. And let's say this time is 10 millisecond, and this one is, let's say, 20 millisecond, and then it repeats itself, okay? So this is one period. And they say, okay, what is the effective value of this signal? And not to confuse the issue, I'll just call this signal x of t. You cannot really say that this value is equal to whatever divided by square root of 2, because this is not a sinusoidal signal. That will not apply. In this case, you literally got to sit down and say, okay, if you want x RMS value, or in our language, x of effective, what I have to do, I have to figure out 1 over the period. What is the period? In this case, the period is 30 times 10 to the minus 3. And so, okay, I got the period. Then I have to integrate this over a whole period. So this has got 2 different values. I've got to integrate it from, let's say we call this 0. I've got to integrate this thing from 0 to 10 to the minus 2. That's 10 times 10 to the minus 3. And that's 3 volts during that time. And then I have to integrate it from 10 to the minus 2 to 30 times 10 to the minus 3, this interval. And at this interval, the value is minus 4t dt. And remember, these have to be squared, right? You have to square these. And then when you're finished, you have to take a square root of the whole thing. And that is your answer. Now, as you can see, it's not as simple as the other case, but you kind of get the idea of how to do this work if you need to find the effective value of certain signals that are not necessarily sinusoidal signals. That brings us to the end of this conversation of terminology. Just remember, anytime you see an effective, that means Vmax over square root of 2, or I effective is I max over square root of 2. And this, of course, all is contingent on assumption that the signal is sinusoidal. It's called sine and cosine signals, okay? So that's really important. Otherwise, you got to do this stuff. Take care and see you in the next video.